Hello, it is Dr. Lou. In case you have not watched the prior videos, I am the lead faculty member who has created the online laboratory classes using kits from Science Interactive. In today's video, I'm going to go over the unique properties of water. We're going to look at water. Let me draw the Lewis structure for water. What is sitting on top of the oxygen in the Lewis structure would be two lone pairs. Water is a polar molecule, so I can draw two arrows labeling the polar bonds. Now I'm going to label each hydrogen as delta positive, and I'm going to write two delta negatives over the oxygen. Because water is a polar with OH, water undergoes hydrogen bonding. Water, because it has two delta positives and two delta negatives, can form four hydrogen bonds. So I'm going to write 4 H bonds. Because water can form four hydrogen bonds, it has very unique properties. There are many other molecules that form hydrogen bonds, but there are no other molecule that is this small and capable of having four hydrogen bonds. The main unique properties is there is going to be very strong cohesive and adhesive forces in the water. So let's look at cohesion. So cohesion means water molecules stick to one another. Now let's look at adhesion. So water molecules stick to the surface. Let me give you a few examples. I have a picture of water pouring out of a faucet. Why does water come out in a stream coming out of the faucet? The stream is related to cohesive forces. The water molecules like to stick to one another and come out into this steady stream. Let me give you another example. So on the right side, we have alcohol. On the left side, we have water. So notice how it might be hard to see. The alcohol spreads out the water forms a dome shape. So adhesive forces stick to table. So there is adhesive forces for both the alcohol and the water, but if you were to tip the table over, you would see that the alcohol would pour off a lot faster because the adhesive forces are a lot weaker. And then we have cohesive forces makes the dome shape. The alcohol, in this case isopropanol, looks something like this guy. Because there is only one hydrogen attached to the oxygen, we are only going to be able to form two, not four hydrogen bonds as is in the water. So in the first part of the experiment, you are going to be looking at a needle floating or suspended in water, and you're going to relate the needle floating or suspending in water versus sinking based on adhesive, cohesive forces and surface tension. In the second part of the experiment, you are going to add water drops on top of a penny and add paper clips into a glass of water, also to demonstrate these kind of forces. Be sure when you are explaining the results that you explain them in terms of adhesive and cohesive forces. Last, we want to look at capillary action. So if I take a capillary tube is just a small open-ended tube. So if I take this capillary tube and I submerge it into a beaker. Let's see if I can draw my beaker. Yes. So I put this capillary tube into a beaker of water. What happens? The water will flow where? Up the capillary tube. So why does the water flow up the capillary tube? So it is capillary action. Capillary action involves adhesion to tube. And what else does capillary action involve? Capillary action will also involve cohesion of water molecules to each other. we will use dyed water with food coloring, and a stalk of celery in order to look at capillary action. So when explaining capillary action, I would like you to make use of adhesion and cohesion.